In this video, we'll be talking about filtering and mapping our data with ForMAPL. So in the previous video, we talked about importing the data formats we need to be able to use our data in ForMAPL. So now we'll go about filtering and mapping that data in real time. So since we're following along from the previous video, I have my ForMAPL app already opened up right here. And so here in the filter tab, we can go ahead and get started. So on the left, you'll notice we have two things. We have app columns and user columns. On the right, we have a preview of the first 15 rows of our data and some buttons to apply our filtering and to clear it. So let's discuss the app columns. So the app columns are columns that are required by the app ForMAPL to run, such as our plot IDs, our measurement years, our species, our diameters, and also calculated by the app are the trees per unit area and basal area per unit area, using your units that you are included with your data. Then the user columns are everything else. So any column that is included in the data, such as our state codes, forest type, and forest name. I included these with the CSV file that I uploaded. And also any variables that come from your polygon geometry, such as the forest regions, etc., and the forest surface polygons. Those are also part of our user columns. So we can think of it as the app requires core columns, those are the app columns, and then everything else is in our user columns, which we can use for filtering, mapping, and plotting. Okay, so the basis for filtering, it's similar to what you would have used in things like Excel, Google spreadsheets. So for our categorical and integer variables, we have dropdowns. So if we want to look at, say, a year 2015, we can choose that. And for our continuous numeric values, we have sliders. So we can drag our sliders around. And let's say we want to look at merchantable trees between 10 and 30, let's say 10 and 30 inches. So we can drag our sliders there. Let's say we also want to look at something with our user column, such as something in Michigan. So let's say we want trees from Michigan from our user columns measured in the year 2015, the diameter between 10 to 30 inches. We can go ahead and press apply filters. And now we can see we have our state Michigan. Our smallest diameter is 10 inches. And the measurement year is 2015. So filtering is pretty straightforward. And again, if you've ever used filtering before, you'll know how this works. So if you want to go ahead and clear the filtering, you can press the clear filtering button, and it will go ahead and reset your data back to its original state. And a couple more things here. Next to the sliders, you may notice an NA button. So what this does is this, by default, if this is checked, this will keep any missing values in that column. So let's say you have missing diameters in one of your plot measurements, but you still want that to be included for things like trees per acre. You can keep this checked. This will make sure any missing values in that column are retained. So if you uncheck it and you press apply, it's going to drop any columns or any rows in that column that are missing values. So by default, everything is kept. So we make sure that your data is intact the way you uploaded it. But if you want to drop any missing values with the sliders, you can do that there as well. Let me go ahead and clear this. And one other thing in the filtering tab that may be of use is we have this column here called in geometry. So if you upload polygon data, this allows you to select points that are either inside your geometry, so a 1, or outside of the geometry, a 0. So let's say we uploaded our forest surface shapefile boundary. We only want to include our FIA plots that fall within that shapefile. If we select 1 and click apply, you'll see here on the filtering on the data, our in geometry is 1, and our plots have changed. So if we go ahead, and this ties in nicely to the next section, which is the mapping section, we come over here to our map, we can see we have our polygons in blue, and our points shown here as dots. And you can indeed see that all of our points do fall within our polygon boundaries, which is quite nice. So there's our points within our forest service boundaries in our map. So this brings us into the next point, that everything you do in the filtering tab gets sent to the map tab. So any filters you have applied, that's what the map has available to work with. So for example, in the filtering tab, we go ahead and clear the filtering back to default. If we go back to our map tab, you'll see that we now have all of our points available to us. So just make sure that the filtering essentially allows you to refine what you want to see on your map. So if you're not interested in a certain region, so let's say we're only interested in Michigan or a certain state, we can select that variable from our filtering tab, and we will only see that in our map tab. So that's the filtering. Now we can move on to the mapping. So in the map tab, what you'll see is on the left-hand side, you have your styling and your filtering. And so this filtering is different than the filtering that we have in the filter tab, in the sense that this filtering is on demand. So what we can do is we can filter in real time. Let's say we want to look at states such as Michigan. We select Michigan, we will only see that in real time on our map. And again, we can go ahead and clear filtering, etc. The reason there's a separate filtering tab is with the mapping we have leaflet, if we have a variable that's constant within the plot, we can just change that on the map on the fly without having to redraw the whole thing. So the variables you see here are what we call quick filtering. So any variable that shows up here, you can filter. So like, let's say, for example, we want forest name. We can do Hiawatha National Forest, and instantaneously we will see just those points. And we can see they do indeed fall within those shapefile boundaries. And so the filtering here is fast. So it might be a little bit redundant with some of the filtering you see in the filter tab, but this filtering in the map is on the fly. So I'd recommend filtering your data in the filter tab. Just find the core variables that you need, or else you might be able to find some of them here on the fly visualization. Again, everything that is sent from the filtering tab, that's what the map tab will see. So a couple of other things in the map. So the map itself, we have options to zoom here with these plus and minus icons. We can draw polygons to make selections. We can add rectangles as well. And we can modify these with this button. We can drag, resize, and we can clear our selections if we want to as well. And on the top right, we have an option to change how our map looks. So we have light mode, dark mode, satellite, street, and topographical maps. We can also show just our point layers or hide our polygon layers as well, depending on what we want to see. We also have options to control how our map looks. So we have this base map feature. So if we, by default, it shows the individual plot key, but we can change that to any variable we want. Let's say we want to look at state code. So we structure our data to show it by state. So we have Minnesota, Wisconsin, Michigan. We can change this to show by forest name, for example. So now what we'll see is we have our legend showing our forest names and the NAs in gray. So if we go ahead and resize our points here, we can see this a little bit more clearly. It will apply whatever that base map is to our points, so we can see that there's the forest regions, and everything else outside of that is colored in gray. We also have a couple of variables that are calculated by the app itself, which is total trees per acre. And you can see we go ahead and disable the polygon layer. These points a little bigger, as well as make them transparent. Here we can see we have total trees per acre. And so for a lot of this region, it's quite low. We have a couple of higher TPA values over here. We also have things like total basal area per acre as well. Again, we can change the size of our points. We can change the opacities if we want them to be completely transparent or completely opaque. We can do that as well. And if this map looks a little bit blurry to you, that's just because I have the app zoomed in. Typically, it'll be much higher depending on the resolution of your monitor. Just for this demo video, I have the app size compressed a little bit, and so the points do appear a little bit blurry. We can also click on points. So if we click on a point, it'll tell us our plot ID. And if we don't like this color palette, we can simply select a different one. So we can select this one. We'll change our color palette on the fly. Oranges, purple, blue. Any palette you would like, you can choose here. Let's go back to what I like, which should be Which one was that? Yellow, green. There we go. So we also have a couple of options down here to rescale our palette. So if we have categorical or continuous numeric data, what this will let us do is if we click Rescale Palette, it will rescale the palette according to a normal distribution. So we can see that 25 to 75% of the data falls within 50 to 127 total basal area per acre, and so on and so forth. So we can go ahead and rescale that. You can see the difference there. And then we have this Fix Palette option. So what fixing the palette allows you to do is, let's say you're filtering your map and you don't want your legend to change, you can go ahead and fix this in place. If I turn this on, go over to our filtering. First of all, let's make this our base map, our state code, so this is easy to see. So we can see that right now Wisconsin is in dark green. So if we have fixing the legend enabled, we go ahead and select Wisconsin, see that Wisconsin stays dark green, because fixing the palette fixes the colors to your entire data, not just what you have filtered. So if I go ahead and uncheck Fix Palette, you'll see Wisconsin becomes the highest order color in that palette, which is light yellow. And so again, you can see there Wisconsin by itself, without fixed, is yellow. With it fixed, it's green. And if we go back to the full data, you'll see that it's dark green, because that's where it falls in the data set. So fixing it fixes the data to the entire scale of your data, so it'll always stay the same color if you want. But if you want it to change based upon the filtering, you can do that as well. And so those are the main options for filtering. We can do things like take a look at the total TPA, so we can drag this slider in real time, and we can see how many of our plots fall within a certain trees per acre. You see there's a really high plot up here with a crazy amount of TPA over here for some reason. But you can see most of our plots kind of fall in that more typical TPA range. You can also have filter by basal area per acre, so we can drag these sliders in real time. You can see how those change, as well as a couple of diversity indices that are calculated by the app itself. The Shannon-Weiner Diversity Index. You can see what plots fall in those different indices. Species richness as well. You can see we have plots with species richness of 1. It's quite a few. Let's check about some high species richness, which let's say 12. There we go. And species evenness too. So we can see how even the species are. So there's a lot of plots that have species evenness of 1 and none that have 0, which makes sense. We also have quadratic mean diameter we can filter by as well. So again, you can filter your map in real time. Okay, so we go ahead and clear this. So we have our filtering, our mapping. We can style our map, we can filter our map. Now what can you do with these points? This is where the geometry selection comes into play. So if I make a selection with my tool, so we want to look at Isle Royal, for example, and come here, I can make a selection around the points that I'm interested in, press Finish, and it's going to say Selection Applied. So what this is going to do is to take these points that we've selected and send these plot IDs into our Plot tab, which lets us visualize metrics about our data. So we'll talk about this in the next video, but if I come to Plot, you can see the points that I've selected, we immediately have a diameter distribution ready for us to use. So we'll come back to this in the next video.